And x belongs to the set of whole numbers. Okay, remember the whole number is the symbol with an O here. Okay, so we have the set of x, and x is greater than 3, such that x belongs to the whole numbers. And we know right away for our whole numbers, in terms of our definition, the whole numbers would be starting from 0, and we're going 1, 2, 3, and it will be going right 4, let's go 4, 5, and going right up to infinity. Okay, and that is what our set, okay, of whole numbers. Now this time it says x is greater than 3, so it means therefore the members or elements we're looking for would have to begin from 4, 5, 6, and we go on, okay, right up. Now there is a similar situation in terms of drawing this or representing it on a graph, where you can have 1, where we can have 0, you have 1, we have 2, 3, 4, then be going up 5, 6, going all the way up to infinity if we have to. This time, what are we saying? It says it's greater than 3, therefore 3 is not involved, so we'd have to put a clear circle around 3, and then to start going all the way up, extending, and it would be x is greater than 3. So anytime it's just greater than or less than, that particular number is circled and left with a clear circle. All right, so that is where we're starting with for that. And of course, yes, you can tell me, because you're following in your books, that when we had less than or equal to, that circle was darkened because the number was included. Similarly here too, if we had a situation where we were looking at the inequality which stated that x is greater than or equal to 3, we would have identified the area 3, circled it, but this circle would be darkened to indicate that it is included, and then our arrow would have been going all the way up, okay? And this then, so we can write it x is greater than or equal to 3, okay? And the whole thing here would be darkened going up. So this is what we're talking about when we say how we'd be representing these things. So when you get to your multiple choice papers and they're asking you which one of these represent the graph, x is greater than or equal to 3 or x is less than 3, because we have this information, you're able to identify it. All right, and it is as simple as that. Do not be afraid of patient. One by one, and look and read it, put in the mathematical meaning to the symbols you are given. You can see that it is just a shortened form of what you know in terms of a whole sentence. All right, now let's look at it. What do we do when we get an inequality and they're asking us to solve? So again, we know what we should have been doing when we get the linear equations. What do we do now when we get the inequalities? So we're going to look at a few examples, all right?
Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem. including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
Okay, suppose we were given to say solve the inequations where we had t minus 4 and it is less than 3. T minus 4, it is less than 3. So here we go. Again, it operates like what we know already for equations. What are we going to do? All the terms that are alike will stay on one side and the other terms will go to the other side. But this time there is something else we have to take care of. It may not come out in this first example, but we will see. So we want to find t. So t will stay on its own here, t, and we must take the number -4 to the other side. And as it crosses, this also acts like equal sign here. As it crosses from one side to the other side, it is going to change the sign. Why do we change the sign? I will show you. If we have -4 and we want it to be 0 because we don't want it there. If we have -4, we must add a +4 and say it's less than 3. And we will be saying what we do to one side, we have to do to the other side. So we also have to add. We are adding here +4. So we also have to add a +4 on this side. Okay? So before we start jumping and telling you take it to the other side, we're saying why are we taking it to the other side? First, we don't want it, and in order to make things disappear in terms of inequalities or even equations, we have to make certain that we can make them into ones or zeros. Okay, so here we have a -4. We want it to disappear, so we're adding 4 to both sides, and then we'll be left here with t. No, this would just go 0, would be less than, and 3 + 4, 7. And that's the answer. All right, that is the answer. Now, let us look and see what would happen when we have this in terms of the inequality. So we have 3x. So that's example 1. If we had example 2, so you had 3x and it is -22, and this is less than, and it is less than 8x plus 18. Less than 8x plus 18. Write the equation. Okay? Write the inequality. 3x minus 22 is less than 8x plus 18. Notice I'm correcting myself every time when I say write the equation, because it's not an equation. Okay, it's not equal on both sides. It's actually saying it's less than. If you change it to an equal sign, you have changed the sum and the whole thing is wrong. So that is why every time you have to make certain that you're using the right terminology. All right, so here we go. In this inequality, we operate again. What are we going to do? We are collecting like terms on one side, and now we understand the whole concept of saying we're crossing. Once we're crossing from one side to the other side, we're changing to the opposite sign. Opposite sign meaning opposite operation. If we're not subtracting, we would be adding, and if we're not dividing, we would be multiplying. Okay, so this time we're writing back again. It is 3x. The 8 is on this side, so we're putting it to the other side, so it comes over as, and it's a positive over here, so coming over to this side is -8x Then we write less than, you have 18 because that is not going anywhere. And then it is a negative, and we're taking it to the other side. So it is a positive sign, plus 22. Okay? Now 3x minus 8x, which number is bigger? And it is the 8 you're going to tell me. And by how many? And it is negative 5x would be less than, and when we add these two numbers, you can see right away that we'd be getting 40. This operates the same way as equations, that we can never find a negative variable, so we have to change the signs. But listen what happens this time. Negative 5x is less than 40. We're changing to a positive. So if we go positive 5x, this time, this sign also has to be changed from a less than to a greater than, and we have to make this a negative 40. Again, we'd be saying we don't want 5x, we want 1x. So what are we going to do? We divide both sides by 5, and it's greater than, and it's negative 40 divided by 5. And then, so we can get x then is greater than negative 8. And that is the answer. All right, check on it and see. When we do our equations, the equal sign does not have to change because it will be the same thing. But when we're doing this and we're changing from a negative, so look out for this, from a negative to a positive, everything gets changed for the inequality. Study that example and tell me if we understand what was taking place here. Now you have a lot of symbolic things to do in terms of mathematics, so study that for a while and I'll be back again to give you some more. And ladies and gentlemen, this exercise would not be as interesting and as enlightening as it has been if it weren't for the beautiful people that I work with in this EBU department here from the Ministry of Education. And I think about people like Jetta Charles behind that camera. So you don't tell me that I've given you wrong stuff because he's sharp. And I have Aisha Lynch, sweet as the Black Antigua pineapple, and Maggie Harris, that eagle sitting around there and crowing, and of course Sylvanus Barnes, ready to bring us the mathematics poem. I'm going to read you one of them that he wrote. And the boss of the whole show, Mr. Philip Lloyd. Thank you very much. And these people make the Antigua Barbuda education system tick for us. We'll be back again.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.